Welcome all to this lecture series on ESP32. I am Priya, working at Entity Intelligent Devices and Smart Solutions. This is fourth lecture of Module 2, FreeRTOS and ESP32. In this lecture, we will see task management. In that, today we will see priority of tasks and how it affects the execution of itself and other tasks. Then we will change priority of task during the runtime. The tasks we created in the previous lectures all had same priority. So now let's create tasks with different priorities. The scheduler always ensures that the highest priority task runs, but in the examples till now, we had created tasks with same priority. Thus they were running in turns. We had two tasks. This is time scale and two tasks. Tasks and 8 interrupts. So when the scheduler is started, it is started task 1. These are the time slice for the period. After every time slice, the scheduler executes and it runs the tick interrupt. The tick interrupt selects the highest priority task in the round robin fashion. So it happens, it selects another task of highest priority and it starts executing task 2. It executes for business time, then again tick interrupts happens and it selects task 1. So like that we continued running. So now we will see what happens when we create tasks with different priorities. So let us start Visual Studio Code. Close this folder. ESP in new project. I'll select v6.0. Select project directory. Give a suitable project name. And here I will give module 2 lecture 4 and we will give all our lecture 4 files in this project itself. Use template, extensions ESP and choose hello world. Create project using template. We'll open the new window. Close our old window. I have already connected the diskette to the computer. So our ESP our communication port and ESP32 target device are temporarily set. We will delete everything in this file. We don't have any build folder now as we have not built it. So our IntelliSense may not work at this time. We can try it. For ESP IDF FreeRTOS, it is not working. It is not showing any suggestions. So first we will build it. After compilation, in the build folder, it has created compile commands.json. But still our command may not be recognized. Let us check it. Next task. Still no suggestion. For this, we'll go to Files, Preferences, Settings, Pencils, C++, and Compile commands. Edit the settings.json. The build file, we'll just copy this name. Save it. Then we'll check our license. Now it has started appearing. Now we are set, we can start. We will rename the file. We will name it suitably. We are working with priorities, so I'll name it priority. Since we have renamed it, we need to change our cmake.list.txt also. I prefer copy pasting the part as it won't show any error if we do any type. We'll build it again. It was successful. We'll start. Let us create a task entry function for the task. It takes void pointer as parameter. We have defined our tasks function. Now we will create a task using this entry function. Declaration of the function is here. Now we will create a task using this function. The definition of the function we will give at the end. we will still be using pinned to core version. Task function, task entry function, text parameter, descriptive name to the task. We'll give it simply task 1. Start depth, size of start 4096. 4096 bytes. We won't pass any parameter in priority of this task 1. Then there's no handler. Then we will run it on core 1. Similarly, we will make another task. Now the definition of the function. The signature of the task entry function will always be seen. It will return a void and it will have a void pointer as parameter. Still, we will be working with a loop to create the delay for us. So for that, we'll create a variable count. We'll start our infinite loop. A task entry function should always have an infinite loop so that it does not exit the function. And if it exits, then we will delete it properly. Let us get name of the task also. Since we are using only one task entry function and we are creating two tasks using that, so it is better to take some parameter when the task is created and that we will catch it here, we'll print it. Since parameters are being passed, we will make a character pointer to catch the address of the string literal that is being passed. And since this is a void pointer, we need to cast it to character pointer. Now we have our ping also available, so we will print it. task name. Then we will wait for some time. We'll do it in the crude way. Just empty loop. Static. Const. So now we have two tasks created from the same function. We are passing parameters, names of the task as parameters. We will build the program. We will flash it on our microcontroller on our dev board. We are using UART. Then we will monitor it. So now we'll analyze the result. What has happened? We can see that as I have been created two tasks, task 1 and task 2, and in the output we are seeing only task 2. From task 2, there is no task 1. Why this is happening? We will analyze it. So we have two tasks. These are the X interval. As the tasks were created, task 2 had highest priority. So it started running at the time in at the tick interrupt. The ISR was called. It ran, it selected the highest priority task. So it selected 2 and 2 started running. Task 2 started running. Again at the tick end. Again at the end of tick period, tick interrupt was called. It selected again task 2. Again tick interrupt was called. So like this only task 2 was running. Task 1 never got a chance to run. So this is what happens when priorities of two tasks are different. The task with higher priority will always occupy the processor and keeps running. And it even doesn't allow idle tasks to run. So we can see it will many a time it will be reset. We will monitor again. Then we will see in between the core getting reset. The following task user did not reset the watchdog in time. We will stop the monitor. So idle task 1. The tasks currently running was task 2 on CPU 1. The idle task could not reset the watchdog timer. So the processor was getting reset. Now we will try to change the priority of the tasks at the runtime in such a way that we can give chance to another tasks also to execute. But this execution will be hard coded as we will be manually modifying the priorities of the task at the runtime in priority such that the priority of the running tasks becomes less than the priority of the waiting tasks. So let us declare two more task entry functions. Alternating function 1 takes void as one more task entry function definitions of the task we will at the bottom. We could have written the definition of the task entry function here itself, but I prefer it this way. We will define a variable of type face type. Actually, it is nothing but int. Another one for counter. And we will store the current priority of the task in this variable. This UX priority variable. UX task priority get. It is an API that returns the priority of the task. Suppose if we pass null here, then it will give the priority of the currently executing task. And suppose if we put some task and left here, it will return the current priority of that task. So here we want the running tasks priority, we will pass null. And we will have one infinite loop. In some statement. Once it has started running, So now we will increase from here we will increase the priority of the non-running task. Says that in the next tick when scheduler selects a task, it will select that task. So we will make two tasks. First let us create tasks itself. Says that we have handlers also. We will make two handlers for the two tasks. We will create more tasks. Here in place of null, we will put a task handle for the tasks. We'll pass parameters also. Task entry functions. We are creating one task using the task entry function. The task alternating one, aimed at task 1, stack size 4096 bytes, from task 1, priority 1, we will give task 2 higher priority, task 2 handle. We are creating two tasks using the two task entry function. Now we have two handles here. So these two handles we will be using to change the priority. So after we have printed this task, but let us start with writing with task 2. We have given task 2 higher priority. So when the scheduler starts, it will start the task 2 first. So let us begin it in that flow. This much portion will be, we can copy it from here. Infinite loop. Print statement. Printf. Task is running. We will use another function similar to this, view task priority. Set to change the priority at the runtime. It will take two parameters. First the task handler and the priority towards this task will be running first. So after it has executed, we will increase its priority less than the priority of the another task. So we will subtract 2. As task 1 has priority 1 and task 2 has priority 2. So after subtracting 2, its priority will become 0. But idle task also has priority 0. So it is better to not keep it 2 and we will keep it 3 and here we will keep it 2. That way we will be same. So now the UX priority is 3 and we are subtracting 2. So now this after it has start execution, the priority will change to 1. We will give a delay. One variable I feel this completes our task 2 definition. Now we will go to task 1 definition. When this task will be executing, its priority will be 2. And the task 2 priority we had decreased to 1. So now here what we will do? Increase the priority of the task by 1 such that again the task 2 priority is greater than the task 1 priority, and in the next tick interrupt task 2 is selected. So we will use the function set priority. But here we won't change task 1's priority. It will be fixed. Our task 2 priority, we made it 3 initially, and our task 1 priority, we made it 2. So when task 2 started execution, when task 2 was executing, we changed the priority of task 2. This line. We decreased the priority of task 2. So now task 2 has priority 1. Still T1 has priority 2. So T2 next tick T1 will be selected since it has priority 2. And in this here we will change the priority of T2 again, that to T. So now again T2 has priority 3. So in the next tick T2 will be selected. So we will do it here. We will put the task handler of 2 edges. And we will increase it. The priority of task 1 is 2, and now we'll make it greater than So what we are doing is at the start, even had priority. So into had priority feed. And so at the start into was it. Think one even had priority 2 and into had priority 1. Here even was it. Again at it. Even had priority 2 into had priority A. Into will be selected. Like that, T1 and T2, T2 and T1 and T2 and T1. Like that it will continue. Now let us see the execution. We will put one delay here also. We'll save it. Build the program. We made one mistake here. In the set function, it doesn't return anything. It will be of type C. Here also. We'll save it. Here we need to pass the address of. We'll build it. We'll flash it. And we'll monitor it. Task 1 and task 2 are alternating. We'll just clean it. Build it. Flash it. And monitor it. So we can see now task 1 and task 2 are running alternatively. Task 1 is running, task 2 is running. So in this lecture, we saw the priority of the task, how it affects execution of other tasks, and how we can change the priority at the runtime, and how we can manage alternating the task by changing the priority at the runtime. That's all from this lecture. See you in the next lecture. Thank you.